Morning everybody. Wanted to bring you up to snuff on what it took to make these adjustments. What we're looking at is the disc with the slots, and up in here the LED sensors. They go right here, and all the wiring comes up to the PC board. I've got 1 and 4 LED sensor here, 5 and 8. Then on the second board I've got 3 and 7 and 2 and 6. And I've got individual powers for each board, but the grounds are connected together between the two boards on this front edge. And so the next step, I've already measured the individual LED sensors. So the next step will be to follow that signal through the circuitry before I connect up the motor with the 12 volts on it to run it. And I'm going to run the motor on a couple of these small 12 volt batteries like I did with the prototype. And this was quite a bear getting this thing to go without touching. And what I ended up doing, I ended up with one screw here to press on this aluminum plate, and then I had to add a shim here because this area here was going at an angle, and before that I had to go around in back of this copper plate with the I took individual pieces of paper and some thin pieces of copper to make some shims to get this thing, so when I spun it I was able to get it to be perfectly flat when it was spinning instead of going at a wobble. And the way I did that, I mounted this piece of wood here, and then without the LED sensors on there, and then I used a piece of plexiglass on top of that wood with a clamp right up against the copper plate, and made adjustments as I was turning it around. And this is the direction it's going to go. It's going to be clockwise. You can see it's really awesome. I mean, it just doesn't take much energy to turn it, and it's perfectly balanced as far as I know. I did goop. The copper disc is gooped after all the alignment is done. I'd already previously gooped it, so I took an X-Acto blade and went between the pulley. I don't know if you can see it or not, but I went between the pulley and the copper plate and loosened it on certain areas, and then I marked it with these lines and these lines here, and then adjusted it accordingly. And so the next step, I'm really got to be careful about stuff falling down in here. This would be a nightmare if a washer fell down inside this motor. I mean, so I'm going to take and plug up these holes and make sure this thing is sealed, so screws or nothing can fall in there. And I don't know if you can see it down in there, but that's what it looks like. The next step is this area of this board will drive positive and negative pulses here, and then the common return back to each of these connectors is here. Same thing on this board over here. It's going to drive the odd coils are here in parallel, 12 in parallel on each of the stators, so that's 4 times 12, and then these are connected in series, so I've got 48 coils, groups of 12 in series, so the 96 coils are all in parallel groups in series. That's about it for now. Next step is to follow the signal through the circuitry, make sure that's all working, and then also go over here and do the test on the comparators. Make sure, I may have to modify the resistors here to get them to do this right. And after that, then I've got to finish up this system here. The bottom half of this Tesla coil system all is functioning. That's what I used in previous videos on the multi-wave oscillator. I've got the Barker-Williamson coil back there, some diodes, and I got my high voltage caps back in the back with some wires, and this needs to be rewired up. And then that's going to fill that's going to fill these two groups of caps like it did before with the positive and negative energy. That's sampled by these comparators in here through these connectors, and that once it reaches its level, which is preset with a pot right here. Now, well, on the car, these two come out and they're wired to a double pot. So when you turn that pot with the gas pedal, it changes the voltage level on the operating system for this piece for the output. And the 1000 volts comes in here. These can handle 2000, and positive and negative, they're going to be used to charge up the blue capacitor banks. And when they finally reach their level, this comparator says shuts him off, and that I know that all works so far, so we shall see. Anyway, that's where we are today. Have a go.